Welcome to this video on using Power BI with Analytics Solver. Power BI is Microsoft's desktop or cloud-based interactive data visualization business intelligence tool. In past versions of Analytics Solver, users have only been able to upload their model parameters, or model data, to Power BI after solving an optimization or simulation model. Analytics Solver now includes the ability to turn your Excel-based optimization or simulation model into a Microsoft Power BI custom visual. That is your full optimization or simulation model ready to accept Power BI data, run on demand on the web, and display visual results in Power BI. This video will teach you how to do it. In order to use this new feature in Analytics Solver, you must first install Desktop Power BI or the free cloud-based version of Power BI. For more information on this business tool, see the following website. It is important to note that in order to create a custom visual in Power BI, you must first install Power BI's developer tools, which is comprised of Node.js and the Power BI tools. To install Node.js, open a browser and browse to the URL shown on screen. Click the Download version 6.11.4 LTS button to download Node.js for 64-bit Windows. When asked what to do, click Run. Once the Node.js installer is downloaded, run the installer and follow the directions on the installer dialogs to install Node.js onto your machine. Install the command line tools by opening a command prompt and typing the following command. After clicking Enter, you'll see the following results in your command prompt window. Now that the developer tools are installed, we can move on to a small optimization example in Excel. In Excel, click Analytics Solver, Help, Examples, and click Optimization Examples, Product Mix to open the Product Mix Example Optimization Model. This model determines the optimal mix of products that a company should produce in order to maximize products. The optimization model is included in the Model tab on the right. This model, written in an algebraic form, is shown on screen. The engine selected to solve this model is the standard LP quadratic engine, as shown on the Engine tab in the Solver task pane. Select a blank cell, say cell J6. Then click Formulas, Insert Function to open the Insert Function dialog. Then select PSI Dimension and then select PSI Data Source. The Function Arguments dialog opens displaying 5 arguments: SRC name, data, IDX1 name, and IDX1 element. We will use this dialog to create a PSI data source function in cell J6 that will allow us the ability to expose certain parameters within the product mix example model. By using this function, we are able to specify the model parameters in the Excel model that could change in the future or that we are interested in seeing in Power BI. The amount of inventory on hand for each part, the profit point for each product, the number of parts that make up each product, or the selling price for each product. The first argument is the SRC name argument. This argument names the text file created by the custom visual which is submitted along with the RACON model to the RACON server. Here, I'll type inventory SRC. Data name. This is the name given to the data well that will appear in Power BI. This data well will hold the actual data. So I'm going to type inventory. Here, I'll enter the Excel range where the data is located on the spreadsheet. For this example, I'll click the upward pointing arrow, and then I'll select cells H18 through H22. These are the available inventory by part. I could also simply type this range into the edit box. Now notice that our selection automatically changed to number underscore available. This is because cells H18 through H22 have been assigned to this Excel defined name. For IDX1 name, I'll enter the name of the first index set for the data specified in the data argument. In this example, our index set is simply the inventory available by part. Therefore, I'm going to enter parts for this argument. And then for the IDX1 element argument, I'll enter the Excel range containing the data or the elements for the first index set. In this example, we have cells B18 through B22, which are our parts by name. Since this index set is one-dimensional, nothing further is needed, and I can click OK to enter the PSI data source function into cell J6. Notice that cell J6 now displays the value for the SRC name argument, which is inventory underscore SRC. Next, we will use a second PSI data source function to expose the selling price for each product. I'll select cell J17 and then click Formulas, Insert Function, PSI data source. Our same dialog opens. For source name, I'll enter profit source, since these are the profit points for each product. For data name, I'll enter profit per unit. For data, I'll enter the profit per unit in cells C24 through E24. For IDX1 name, I'm going to enter products because these are the profit points per product. And then for the IDX1 element, I'll enter C13 through E13. These are the names of our products. Again, this index set is one-dimensional, so there's nothing further needed, and I can click OK to enter the PSI data source into cell J7. And notice that J7 now displays profit underscore SRC, which is the name of our source for profit. Finally, we will use a third PSI data source function to expose the number of parts required for each product in Power BI. Note that I could enter this PSI data source function directly into the cell, but for this video, I'll use the function dialog again. So I can click Insert Function, PSI data source. For source name, I'll enter required parts source. Notice that this is a two-dimensional table. There's parts down the rows and products across the top, as opposed to our two previous data source functions that were one-dimensional, our inventory levels and our profit per unit. Since this is a two-dimensional data source, we will need to enter both our row names and our column names. It is important to note that row names always go first. For data name, I'm going to enter parts per product. For the data, I'll enter cells C18 through E22. For the name of the first indexed set, I'm going to enter parts. And note that I am reusing the name that I used in the inventory source function. Remember, our inventory source function exposed cells H18 through H22 and cells B18 through B22. I used parts in that function, and I'm also going to use parts here so that Analytics Solver knows I'm talking about the same parts. So for my elements, I'll use cell B18 through B22. And now I'm going to enter the second index set. So I'll click the tab, and then I'm going to enter products, which is the name given to our profit_source PSI data source function. And I'm going to use the same cells that I used in that PSI data source function, which were cells C13 through E13. Even if I had entered LCD TV, stereo, and speakers in cells C23 through E23, I would not have used those cells for my IDX2 elements. I always want to reuse what I've already defined in a previous data source function. Okay, so now we've entered the row names and the column names. I can click OK to enter the function in cell J8. And here you can see that cell J8 displays required parts underscore SRC. Now I'm going to save the worksheet. And since it's read only, I'll have to give it a new name. And I'm going to save this worksheet to our Power BI folder. Now I'm ready to create my Power BI custom visual. To do so, I'll click Analytics Solver, Create App, Power BI. I'll name our custom visual Product Mix. Now I can click Save. Notice the two command prompts appearing on the screen. It is during this time that your Excel model is being translated into the RACON modeling language and your Power BI custom visual is being created. In order to provide the product mix data to Power BI, we must create a data file. This data file, which will contain the inventory levels by part, along with the profit per unit and the part requirements by product, will be imported into Power BI. This data file can be of any format supported by Power BI, such as a CSV file, a text file, a database file, etc. But in this example, I will use an Excel workbook to hold the data. For more information on what types of files Power BI supports, please see the Power BI documentation at the link shown on the screen. I'm going to open a new workbook and create a table. I'll click Insert, Table, and I will select 5 columns and 16 rows. My table will have headers. In the first column, I'm going to list products. LCD TV, stereo, and speakers. The next column, I'll list my parts. So we have chassis, LCD screen, speaker, power supply, and electronics. And these parts will be the same for all 3 products. In column 3, I'll add profit per unit. And LCDs sell for $75 a unit, stereos for $50 a unit, and speakers for $35 a unit. In my fourth column, I'll enter parts per product. And our last column, I'll label as inventory and fill in these as well. Note that my column headings are the exact same as used in the 3 PSI data source functions. So we have products, parts, profit per unit, part per product, and inventory. If we go back to our Excel model, we see inventory and parts, profit per unit and products, and finally, parts per product, parts, and products. It is important to make sure that there are no leading or trailing spaces in our data source or in our original Excel model. All data for a custom visual must be contained within the same Excel table or from within multiple tables with the same number of rows and columns. I will save this within our Power BI folder, and I'll save this as product mix data. Now I'm ready to open Power BI. Open either desktop or cloud-based Power BI. Click the icon containing 3 horizontal dots that appears at the bottom of visualizations. Then select Import from File. Navigate to the location of the saved product mix file and then click Open. If the import was successful, you will see a message indicating as such. Click OK to clear this dialog. A new icon with the Frontline Solvers logo is added under Visualizations. Click this icon to open Frontline Solvers Custom Visual. Now we are ready to upload our data file that contains the data for this custom visual. Click Get Data, Excel, Product Mix Data, Open. We'll select Table 1, and here's the preview of Table 1, and then click Load. Beneath Table 1 on the right, we see our 5 different columns. Now we're just going to drag our data into our data wells under Visualization. Drag parts to parts, inventory to inventory, products to products, profit per unit to profit per unit, and parts per product to parts per product. Immediately, the RACON model is submitted to the RACON server, the model is solved, and the final variable values are imported back into Power BI. Solver has found a solution. All constraints and optimality conditions are satisfied. This result means that the LP quadratic engine was able to find a solution to this model. No other solution exists that will result in a better objective function, although alternative solutions might exist. In the first chart, we see that the final variable values are var1, which is LCD TV, equal to 200, var2, which are the stereos, equal 200, and var3, which are the speakers, equal 0. These variable values result in an objective function value equal to $25,000, which is the optimal solution to this model. In the chart to the right, we see the final constraint values are the number of chassis used equal to 400, the number of LCD screens used equal to 200, the number of speakers used equal to 800, the number of power supplies equal to 400, and the number of electronics equal to 600. And you can easily see by this graph that the binding constraints are speakers and electronics. Perhaps if we had more speakers or more electronics, our profit could become higher. Analytics Solver now has the ability to solve models within Power BI. There's now no need to go back to Excel to solve your model and then import the results. This concludes this video on how to create a custom visual in Power BI. Thank you for watching.